Welcome, dear students. Now, starting with today's topic, it is one of the most important topic. The topic is regarding the maintenance of ignition system. That what type of maintenance is carried out for the ignition system, whether it is a conventional ignition system or whether it is a electronic ignition system which is used these days. So, what are the key features are there? Because prior to the maintenance steps, we will go through what ignition system is and how it used to work, because the basics should be known to us. So starting with today's lecture, the function of ignition system is to provide spark inside the cylinder at correct time, because the spark voltage is very much high. It is in kilovolts with correct strength near the end of the compression, because timing is also important as well as the strength of the spark is also important, because for timing either the distributor or ignition control module is used, because if you are going for the conventional engine, then conventional ignition system, then a distributor was used. But these days ignition control module ICM is used, because these days distributor less systems are there. And what else is there for uh, the strength is very much high required, because we have to convert very less voltage of battery into very high voltage for a spark to jump across an air, because why it is written across the area of zero point 0.6 mm gap, because we know that the gap of the spark plug is very much low. You can see from the figure also that this gap is very much low. Certain defects figure are given, and the air inside this, the dielectric strength, that is to be crossed. And when the dielectric strength is crossed, then only a spark will be generated. So that much high voltage is required. So how this voltage is generated, it will be illustrated to you through a illustrative video also. The ignition system has to convert the normal battery voltage, that is a 12 volt kilovolt battery voltage of 12 volt to it is wrongly written as 12 kilovolt to 12 volt to approximately 80 to 20 kilovolt. Sometimes it is 40 kilovolt also, means 40,000 volts. And the timing is also important in this, because an example is given if the cylinder is 6-cylinder engine. If the engine is a 6-cylinder engine running at 4000 rpm, then 12,000 spark per minute will be required, because we know that in two revolution, if single spark engine is there, in two revolution, means if the revolution are twice, first revolution and the second revolution, in two revolution of the complete cycle, once the spark is required. So for a 6-cylinder engine running at 4000 rpm, means at every 2000 rpm, and for 6-cylinder the duration will be the 12,000 spark will be required. So timing is very much important in this. And what are the essential parts of ignition system are there? So we will go through one video. The video I have downloaded, that how the conventional system used to work. The video is from popular site. You can refer this site also, because we have referred this site many times for our lectures also. So what are the main components of the ignition system are? They have shown that starting from the battery, when the ignition switch is on, the current used to go to the primary coils, and the primary coil used to get the, because you can see the blue color primary coils are there, dark blue color, light blue color. The primary coils are lesser in number also, and they get 12 volt. And later the circuit is completed through a contact breaker is being shown over here, because in primary circuit the current is to be collapsed after a certain time, because the collapse of current itself will give you high voltage in secondary coil, because this is the coil section. And in this high tension coil section, first is the primary coil, and inside that there are number of turns for secondary coil. This secondary coil will give high voltage when primary coil voltage is collapsed all of a sudden. It means all of a sudden there is a the current has gone. Then in the secondary coil you will have high voltage, and that high voltage is given to the 4-cylinder 1, 2, 3, 4 through this rotary distributor. So this is a simple construction of this system. Although these days each and every cylinder used to have a separate high tension coil and no distributor or contact breaker is used, because what is happening that these days engine control module has replaced the rotary components like this, because in this also one cam is required for rotating, and this also a rotary distributor is required. So both of these are replaced these days, but we should know the what conventional system working is. So starting with the working, the current will flow from the plus minus terminal. They have shown the minus is connected to the body of the vehicle, the plus as the ignition switch is on, the current will go to the primary coil. You can see there are less number of turns and it is of orange color in this video. So the primary coil is shown over here. It will carry the current of 12 volt. You have to complete the circuit, so you will go further with the primary coil, and the current will go to the contact breaker. Now in this, what used to happen, the circuit is completed by connecting to the negative or body, and there is one contact, because presently the contact is there, it means the circuit is complete. The primary coil is having the current. You can see the current is flowing like an arrow. But what happens when this cam will rotate, and when it will break the circuit for this angle, this elevation, this corner elevation, this corner elevation, this corner elevation. These are 4 times in this, because this is a 4-cylinder engine, or n times you can give as much the voltage you require. So this is 4 times they have given. And when this cam used to break the circuit, means open this circuit by its elevation, because it used to push it, the circuit breaks, and this sudden collapse of current, because collapse means current has gone, collapse of the circuit, it will cause a magnetic field induced, and this will cause a voltage of not 12 volt, because earlier the voltage was of 12 volt. You can see in the video the voltage was of 12 volt in the primary circuit. In the primary circuit the voltage was of 12 volt, battery voltage was going. But as soon as the contact breaker will break the circuit, the primary coil will have a voltage of 200 to 300 volts, and on the contrary, the secondary coil, which is having approx 100 times the turns are 100 times increased than primary coil, will have a voltage of 20,000 volts. So whenever there is a contact break, you will get a voltage in secondary coil. Whenever there is a contact break, means a voltage collapses there, you will get a voltage in secondary coil. So this is the main mechanism, and they will illustrate it also. And during contact break, to save this contact breaker also from back EMF, a condenser is used. This condenser is being shown over here, so that the life of this contact breaker can be increased. And this is the camshaft they are shown. In this camshaft, a separate study is used for either to close. This is called close, and this elevation is called open. So these angles are studied for subject point of view later. And how this cam lobe used to rotate is being shown over here. And when this elevation is there, then it used to break the circuit. So they have shown that the circuit used to open and circuit used to close. When circuit used to open, then secondary coil will have a high voltage, that is or 20,000 volt that is required, or 22,000 volt they have shown, and this voltage will be used by the distributor to distribute it to the spark plugs. So moving ahead, the secondary coil voltage 20,000 volt, as illustrated in the video, will go to different spark plug through this distributor. This is a rotary type distributor, and when it get contact with any of the contact, because it is a 4-cylinder engine, so it will give a spark to exactly that cylinder. Means if it is in this contact, there is spark will ignite, and this contact to this, then the particular spark will get ignited. So this is how it used to work, and these are the components. The first component is the battery. I have told you. The ignition switch that was shown to you in the video itself. This was the ignition switch. Starting itself, the battery switch was the ignition switch, and the ballast resistor that is not shown in this video. This resistor is used to control the current also, because in the primary circuit, because a resistor is also there. It is a positive type resistor means resistance increases with the temperature, and this is used to control the current in the primary coil. So this ballast resistor they haven't shown in the video. So for this this figure can be referred, because from the ignition switch there is one resistor and then the primary coil used to get the current. This primary purpose of this resistor is to control the current value of the current in the coil, in the primary coil. And what else is there? Ignition coil, I have already told you in the video, it was mentioned, the ignition coil was shown to you, having the both primary as well as the secondary coils. So this was shown to you clearly. This was the ignition coil, and iron core is there in the center, and this is combined in a single container. These days all the cylinders used to have a separate ignition coil. And what else is there? The contact breaker mechanism is shown over here. So this is the contact breaker that is required to reduce, to get collapse current, and that collapse current automatically, the collapse of the current means breakage of the current, sudden breakage of the current will give the desired voltage that is required. That is being shown in the video also, that they have written whenever there is a contact break, they will get a voltage, because due to break in current and EMF induced in the secondary coil having more number of turns, and this much voltage of 22,000 voltage generated. So this is how it used to work. The capacitor, I have told you that capacitor is used just to save the life of contact breaker, because it consumes the back EMF which is generated when the contact breaker used to work. So the capacitor is being shown over here. The function of capacitor they might have told in the video also, so you can go through the video when you get time. And this is the capacitor is. The condenser absorbs the back EMF they have written from the magnetic field, thereby increasing the life of contact point by reducing burning of the points. So this is why this is being used. The distributor, because these days electronic systems are used, electronic ignition system is used. So what used to be, or distributor less system is used. So these days distributor is not used, but in conventional system this distributor is used. So in conventional system this is being used. So the distributor is already shown to you in the video. Distributor come to the role in later when that particular voltage is generated, and this distributor used to distribute the current. This is being shown over here. And what else is the spark plug? The spark plug is the last thing, because the voltage is to directly given to the individual cylinder. Now this is the complete assembly they have shown. The same thing is there, the battery, the ignition switch. So resistor, the current used to go to the primary coil, and the primary coil circuit is completed through a contact breaker mechanism, which is being earthed. Now what used to happen, you have to break the contact by means of one cam, and whenever there is a breakage in that current, the secondary coil will give the desired voltage, that is of 12,000 volt, to the distributor thing, and distributor will give the rotary distributor. This is being shown over here. This rotary distributor is being shown. It will rotate, and by its rotation, whenever it will touch either of the 6, the spark will be ignited in that particular cylinder. Now these days what we are using is the electronic ignition system. This is called distributor less ignition system. So it can be illustrated through a video. So for this, again a video illustration is given to you. What is happening in this? You can refer these videos from directly from the YouTube also, because a slide portion is being shown over here for illustration. You can directly refer the complete video. What they have done, the breaker point, that is the contact breaker point, they have replaced. Now they are going to replace it, and that is replaced by a armature type sensor. This is used to give the sense to the engine control module. So this is the engine control module, and these signals are used, means engine control system in electronic ignition system, breaker points are replaced by the armature. So this is the armature. This is the crankshaft rotation sensor which is being used, because these days both crankshaft as well as camshaft rotation sensor are used to get the exact position of the TDC of a particular cylinder, and these electronic signals are used to get more precise timing of ignition, and proper advancement and retirement can be also done. So they are using these. The contact breaker is being replaced. So they have shown over here how this signal used to work. And one more video is there, that how distributor-less system used to work. So this is the more advanced thing, that how the distributor-less system used to work, because these days each and every cylinder used to have a separate high tension coil. You can see in the video itself. This is the high tension coil of first cylinder. For second, for third and fourth, means separate high tension coils they have given. So this was the main thing what I was saying, that that's why when they are giving the separate high tension coil, then there is particularly no need of distributor, because they are although the previous video I have shown you, it was electronic ignition system, but this one is currently being used, in which a dedicated high tension coil is given to each and every cylinder. The engine control module consists of coil packs, that is written. The cam position sensor is shown to you, and another is the crankshaft position sensor. Means two sensors are used. One is crankshaft and one is camshaft. Signal of both are used by the engine control module to decide when to give ignition to which cylinder. So this is the main thing, and that is why it is called DIS, distributor less ignition system. So distributor is being completely replaced, and how it used to work will be illustrated through a video. So you can see this video by directly downloading it from the YouTube, and the slide portion I would like to show, that these are the trigger wheel. These are trigger wheel which are being shown, and these are the magnetic sensor. So through crankshaft sensor and through camshaft sensor, both the signals will be used, and signal of both will be utilized to get the exact position of TDC, and then only individual high tension coils will be used. Because when you will see this, when you will take the spark plug of any individual cylinder, you will first take out the individual high tension coil also. For this, you can download some videos that how the high tension coil of individual cylinder is being taken out. Now moving ahead with the subject, the diagram they have figure they have shown in this ignition control module. They have shown that individual high tension coils are there. Although the spark plug are 1, 2, 3, 4, 5, 6, 7, 8 cylinder engine is there, and for 2 cylinder they have used a single coil. So not individual, but means the number of coils they have increased. And this is the trigger sensor or crankshaft sensor they have used. This is the second sensor, the camshaft sensor they have used. Two sensors they are using, and from these signals they have eliminated the distributor and the rotary parts also. So this is how it used to work. What are the advantage of DIS system? Because these days the convention, I have already told you, this was the convention, because convention should be known to us. But these days the distributor less ignition system is used. Fewer moving part, therefore less friction and wear. Flexibility in mounting and location. This is important because of today's smaller engine compartment, and less maintenance required because there is no rotary part is not is there, and distributor cap service is not to be required. Reduce radio frequency interface because there is no rotor to cap lock to cap the gap. And elimination of common causes, because certain times the water or ozone or nitric acid used to form because of continuous spark. So this eliminations of common ignition misfire is also eliminated. Elimination of mechanical timing adjustment is also because you are using the electronic system, and places no mechanical load on the engine. Increase available time for coil saturation, because more number of coils you are using, you have increased the number of coils. And increase time between firing, which allow coil to cool more. So the time also increase because you are using a no more number of coils. So the coil is charging and discharging, the collapse current rate can be controlled. Now we are coming to the main thing, that is the what are the faults in ignition system, because we should know that what faults are there. So overall we are going to cover up the 10 symptoms or faults, and what symptoms are there and what are the possible faults. So starting the first one, engine rotates but does not start. Means engine is rotating but it is not starting. So the reason would be the damp ignition components. I have told you that ignition components get certain dampness, and run out spark plug, because when we see the spark plug also there are several defects in the spark plug, whether it is a deposits, either a deposit it will be covered in the separate lecture, or either it is the coil up, or either it is for this a proper cleaning is required, glaze formation, or excessive deposit is there, or overheat is a different thing, and broken insulator tip for the means that the spark plug is damaged. So these types of things used to happen when means ignition system spark plug run out, and ignition system circuit faults, means circuit fault is there. The second symptoms is difficult to start during cold weather. So the possible faults are run out spark plug. I have shown you the images of run out spark plug. High resistance in the circuit, means the wire I think has broken out, or some loose contact points are there that are creating the high resistance in the circuit, and that's why difficult to in cold weather. Engine starts and stops instantly, means intermediate wiring connections are not proper and the wiring connection are to be seen. So these faults should be known to us. The inconsistent idle means when the vehicle is not running and you have started the vehicle, means the vehicle is at standstill and the engine is started. The reason might be the spark plug gap and faulty ignition timing, because ignition timing is also one of the defect that will be covered, because when we cover the spark plug defects, just after that the ignition timing will also be to be covered, and what we have to do in this will be discussed to you, because timing chain, distributor gear, and crankshaft, camshaft drive gear. So this is the main thing, because timing chain used to give the timing, or means proper timing from crankshaft, means main engine drive, to both the camshaft. If it is a dual overhead camshaft, two camshafts are there, one is for inlet, one is for outlet. So timing chain should be properly given, adjusted. For this a dial gauge is used. Distributor gear means how the distribution is being done to the different spark plug, and camshaft drive gear means camshaft the drive gear, because when we used to give either the power to the one camshaft, or either to that used to give the power to that other camshaft. So drive gear, I think, certain time used to get worn out, and that is also a reason. Some backlash is there in the drive gears, so some timing used to get adjusted by that also, because backlash used to what backlash used to do, they drive the camshaft with not that much proper timing that is required. If certain backlash between two gears is there, means the teeth of one gear, if there are two teeth in one gear and another gear is getting drive from that, and backlash means certain gap, some gap is more due to worn out, some backlash has increased, so camshaft gear drive, that is also to be adjusted. And what else is there? Ignition misfire at idle, means engine misfire at idle means when the engine is running and vehicle is not running, that is called idle position, that you should know. The runout spark plug, faulty distributor, and faulty ignition coil. So we will cover one by one this. Engine misfire on all speed levels, faulty spark plug, all the faults will be discussed to you later, because there is not one fault in the spark plug, there are several faults. So a particular spark plug tester is also used for this, and all the spark plug faults means excessive wear, broken insulator tip, overheat, and deposits, glaze formation, and oiled up and deposits. All these will be covered one by one in the coming lectures. And what else? The faulty spark plug. The next is faulty ignition timing. I have told you there are several reasons for faulty ignition timing. So that is important topic. The reasons are three. There are three reasons for faulty ignition timing. And faulty ignition coil. The coil is faulty because the main voltage is to be generated by that only. Ignition not developing enough power. Engine not developing enough power means the reason is there are several reasons, but if we go for the ignition system itself, ignition timing and faulty ignition coil. Ignition engine backfire, then faulty ignition coil is the main reason. Engine keep running even after switched off means fault ignition timing, carbon deposit, the uh, heated zones are there in the engine, and high speed at idle. Engine knock means the faulty ignition timing, ignition system, electronic fault, knock sensor not working. So one by one we will cover up these faults because beside the spark plug faults, I have told you all the spark plug faults are there. And thereafter second fault, which because three faults we have to go through. The second fault is that which was shown to you was the ignition timing and how it is being controlled. So for this also these three will be discussed. And this the third is the distributor diagnostic means how it is being done. So we'll cover up in next lecture. If any queries are there in today's lecture, then please do ask. Thank you.